Do you know why it's so important to learn how to solve a basic trigonometric equation? By the end of this video, you'll know the answer to this, and by walking through 5 example problems, you'll also know how to solve any basic trigonometric equation. Welcome to Understand the Math. We've created free guided notes that you can use as you watch this video and placed a link to them in the video description below. Trigonometric equations reduce to one or more of the following basic equations. The first one is a sine theta is equal to b, and it reduces to sine theta is equal to c. The second one is a cosine theta is equal to b, and it reduces to cosine theta is equal to c. And the third one is a tangent theta is equal to b, and it reduces to tangent theta is equal to c. I've included a chart to show where sine, cosine, and tangent are positive and negative so that we can easily locate the quadrant where these 3 equations will have a solution. Let's look at the equation sine theta is equal to c. When c is positive, the equation will have a solution in the first quadrant and in the second quadrant because sine is positive in those quadrants. When c is negative, sine theta is equal to c will have a solution in the third quadrant and in the fourth quadrant because sine is negative in those quadrants. The equation cosine theta is equal to c will have a solution in the first quadrant and the fourth quadrant when c is positive, and it will have a solution in the second quadrant and third quadrant when c is negative. Tangent theta is equal to c will have a solution in quadrants 1 and 3 when c is positive, and it will have a solution in quadrants 2 and 4 when c is negative. Let's now go over the steps that we need to follow to solve these types of trig equations. To solve a trigonometric equation, we often need to find all solutions or solutions from 0 up to 2 pi. There are 4 steps that we can follow to solve these equations. The first step is to reduce the equation to either sine theta is equal to c, cosine theta is equal to c, or tangent theta is equal to c. The second step is to determine the quadrants where our solution theta is going to be located. The third step is to plot the value of sine, cosine, or tangent on the unit circle so that we can find the reference angle. And the fourth step is to find the solution's theta. When you're performing step 3 and you plot the value of sine theta, cosine theta, or tangent theta, you first need to find the reference angle in the first quadrant. And then you can find theta in the other quadrants that contain the solution. I've listed the equation for theta in all 3 of the other quadrants. For sine and cosine, when we find all solutions, we get that theta is equal to a number plus 2n pi because cosine and sine are 2 pi periodic. When we're solving for an equation that has tangent theta, we get theta is equal to a number plus n pi because tangent is n pi periodic. Let's remind ourselves that n from 2n pi is an integer equal to 0, plus or minus 1, plus or minus 2, and so forth. Let's now dive into our 5 example problems. For all 5 examples, we're asked to find all solutions of the given equations and then find solutions in the interval from 0 up to 2 pi. Our first equation to solve is 2 sine theta is equal to plus or minus root 2. We'll begin by reducing this equation to sine theta is equal to a constant. We'll divide both sides of the equation by 2, and we get sine theta is equal to plus or minus root 2 divided by 2. Let's now find the quadrants for our solution theta. Let's divide up our equation into the positive equation and the negative equation. So we have sine theta is equal to positive root 2 over 2. And then we have sine theta is equal to negative root 2 over 2. For our first equation, theta is the arcsine of root 2 over 2. And because sine is positive, theta lies in quadrant 1 and in quadrant 2. When sine theta is negative, theta is equal to the arcsine of minus root 2 over 2, and theta is located in quadrant 3 and quadrant 4. If you need to review how to evaluate inverse trig functions like this, you can watch the video I have called How to Evaluate Inverse Trigonometric Functions. We'll now plot the value of sine theta on the unit circle. Our first solution to theta is equal to arcsine root 2 over 2 is equal to pi over 4 and lies in our first quadrant, and this is our reference angle. Our other solution lies in the second quadrant, and theta in the second quadrant is pi minus our reference angle, which is pi minus pi over 4, which gives us 3 pi over 4. Our first solution is going to be pi over 4 plus 2n pi. And then our second solution we found was 3 pi over 4 plus 2n pi. The solution from 0 up to 2 pi is going to be pi over 4 and 3 pi over 4. And we remind ourselves that n is 0, plus or minus 1, plus or minus 2, etc. So we have the positive 1 done. Let's go back up and let's do the negative 1. We'll start by noting that our reference angle in the first quadrant is equal to pi over 4. When sine is negative, the solution is going to be in the third quadrant and the fourth quadrant. In the third quadrant, our angle is going to be pi plus theta sub r. So this is going to be pi plus pi over 4, and it's equal to 5 pi over 4. Our solution in our fourth quadrant is going to be 2 pi minus our reference angle, theta sub r. So this is 2 pi minus pi over 4, and this gives us a value of 7 pi over 4. Our theta is going to be 5 pi over 4 plus 2n pi, and then 7 pi over 4 plus 2n pi. And if we're just going between 0 and 2 pi, our answer is going to be 5 pi over 4 and 7 pi over 4. If you're finding this video helpful, please give it a thumbs up and consider subscribing to my channel. Let's now look at an equation with a cosine function. We'll solve 2 times cosine theta is equal to plus or minus root 3. Let's reduce it to cosine theta is equal to c, and we get cosine theta is equal to plus or minus root 3 divided by 2. Let's split this into our positive equation. Cosine theta is equal to root 3 over 2, and then our equation with a negative constant. Cosine theta is minus root 3 over 2. When cosine's positive, theta is going to be arc cosine of root 3 over 2 on the left, and for the equation on the right, theta is going to be arc cosine minus root 3 over 2. When our c is positive and equal to root 3 over 2, our angle is going to be in quadrants 1 and quadrant 4. When our c is negative and equal to minus 3 pi over 2, our solution is going to be in quadrant 2 and in quadrant 3, where cosine is negative. Our first solution to cosine theta is equal to root 3 over 2 is in quadrant 1, and theta is equal to arc cosine of root 3 over 2, which is pi over 6, and this is our reference angle theta sub r. Our second solution lies in the fourth quadrant, and theta is going to be 2 pi minus theta sub r. So this is 2 pi minus pi over 6, which gives us 11 pi over 6. Our solutions are then pi over 6 plus 2n pi, and then 11 pi over 6 plus 2n pi. So between 0 and 2 pi, our solutions are pi over 6 and 11 pi over 6. Let's go back up to our equation. Cosine theta is minus root 3 over 2. We'll start by remembering that our reference angle is equal to pi over 6. Our solution is going to be theta is equal to pi minus theta sub r. So this is pi minus pi over 6, which is equal to 5 pi over 6. And then in our third quadrant, we'll move it up here a little bit, our theta is going to be equal to pi plus theta sub r. So this is pi plus pi over 6, which gives us 7 pi over 6. So our solution is going to be 5 pi over 6 plus 2n pi, and then 7 pi over 6 plus 2n pi. And our solutions between 0 and 2 pi are just 5 pi over 6 and 7 pi over 6. And we'll remind ourselves that n is an integer. 0 plus or minus 1 plus or minus 2, etc. The third equation that we're going to solve is root 3 tangent theta is equal to plus or minus root 3. We'll reduce it to tangent theta is equal to c by dividing each side of the equation by root 3. So that gives us tangent theta is equal to plus or minus 3 divided by root 3. This then simplifies to plus or minus root 3. Let's remind ourselves that tangent theta is equal to sine theta over cosine theta. And if this is equal to plus or minus root 3, we can think of this as plus or minus root 3 over 2 divided by 1/2. So we can see our reference angle is going to be where sine is equal to root 3 over 2 and cosine is equal to 1/2. And that's going to be for theta is equal to pi over 3. To determine the quadrants for our solution theta, let's write down our positive equation and our negative equation. So our positive equation is tangent theta is equal to root 3, and our negative equation is tangent theta is minus root 3. Our solution to our positive equation is theta is equal to arctan of root 3. And the solution to the negative one is theta is equal to arctan minus root 3. For our positive equation, theta is going to be in quadrants 1 and quadrant 3. And for our negative equation, theta is going to be in quadrant 2 and quadrant 4, where tangent is negative. Just like we did for sine and cosine, we'll look at our positive equation first, and we'll notice that our reference angle is arctan root 3, and that's going to be when theta is equal to pi over 3, as I explained above. Since tangent is pi periodic, we only need to look at quadrant 1, and we don't need to look at quadrant 3. Our solution is going to be theta is equal to pi over 3 plus n pi. And between 0 and 2 pi, theta is equal to pi over 3. And if we add pi to that, we get 4 pi over 3. Let's now look at our equation with a negative constant. We'll remind ourselves that our reference angle is pi over 3. Our solution is going to be in the second quadrant, and theta there is equal to pi minus our reference angle. So this is pi minus pi over 3 which gives us 2 pi over 3. We don't need to look in the fourth quadrant because tangent is pi periodic. Our solution is then 2 pi over 3 plus n pi. And between 0 and 2 pi, our solution is 2 pi over 3. And if we add pi to that, we end up with a 5 pi over 3. And n is an integer. The fourth equation that I want to look at has a secant function in it. Since secant theta is 1 divided by cosine theta, we can reduce this equation to cosine theta is equal to c. We'll begin by writing secant theta is 1 divided by cosine theta is equal to 2. So that gives us 1 is equal to 2 cosine theta, or cosine theta is equal to 1/2. This is very similar to the second problem we did. We noticed that cosine is positive, so our solution is going to be in quadrant 1 or quadrant 4. We know that the reference angle is theta is equal to arc cosine of 1/2, and that is going to be pi over 3. So our solution is going to be pi over 3 plus 2n pi. And in quadrant 4, our theta is going to be 2 pi minus pi over 3. And that gives us a value of 5 pi over 3 plus 2n pi. So between 0 and 2 pi, our theta is equal to pi over 3 and 5 pi over 3. The last equation we'll solve is one where theta is not a known angle, and we need to use a calculator. We'll begin by reducing our equation to sine theta is equal to c. We'll divide both sides of our equation by 4, and we get sine theta is equal to 1/4. Our solution theta is arc sine of 1/4. Since our c is equal to 1/4 and it's positive, we know that our solution theta is going to lie in the first and second quadrants. So we'll write down quadrant 1 and quadrant 2 for our solution. In quadrant 1, we know that our solution is going to be theta, which is theta r, is going to be arc sine of 1/4. And then in our second quadrant, where our other solution is, theta is going to be pi minus theta sub r. And we'll have to calculate what that is. We'll write down theta is equal to arc sine 1/4. We can put that in our calculator. Make sure when you do that your calculator is in radian mode. And we end up with theta is equal to 0.2474. Let's mark this as our solution in quadrant 1. And then in quadrant 2, our theta is going to be pi minus 0.2474. And that is equal to 2.8842. We have two values for theta. Theta is equal to 0.2474 plus 2n pi. And then our second solution is theta is equal to 2.8842 plus 2n pi. If we look just between 0 and 2 pi, our solution is 0.2474 and 2.8842. And we'll remind ourselves one last time that n is an integer. The next video in this series goes over how to solve trig equations containing multiples of angles.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.